Hello everyone. The topic we're going to see is power dissipation. These are the basic terms when it comes related to power dissipation. Instantaneous power, which is nothing but the product of current and voltage. And then we have energy, which is the integral of the previous discussed instantaneous power. And then we have average power, which is just energy divided by time t. These are the formulas for static dissipation and dynamic dissipation. When we come to power dissipation in CMOS, it is due to static dissipation, and the other one is dynamic dissipation. So the total dissipation is given by P dynamic plus P static. The causes for dynamic static dissipation are four. The first one being subthreshold leakage through off transistor. So, whenever we consider a transistor, it only starts conducting after above the voltage threshold. But in some cases, before it reaches the voltage threshold, the transistor starts conducting. So, that time we have subthreshold leakage which occurs then. Then we have gate leakage through dielectric, which is nothing but when in a transistor, if the polysilicon layer and the P substrate acts as a parallel plate capacitor, and the oxide, when it becomes thin, when we have a thinner layer of oxide, tunneling effect occurs. So, due to that, we have gate leakage through gate dielectric. And then the third cause is junction leakage. That is when we have a source and drain and a P substrate. So this source and P substrate, it's going to act as a PN junction. And when this junction is in reverse bias condition, usually there should be no leakage, but sometimes junction leakage occurs. So that is one of the cause for static dissipation. And the last one is contention current. So when we have a CMOS, the thing is usually both circuits cannot be on at a single time. Either the pull-up network will be on or the pull-down network will be on. But in some cases, both are on. So at that time, we have the contention current in ratioed circuits. This will cause static dissipation. And then when we come to dynamic dissipation, there are two causes: charging and discharging of load capacitance and short circuit current. So P dynamic, the formula is given. And then discussing the two causes for dynamic power dissipation, charging and discharging of load capacitance. So we have a pull-up network and a pull-down network. So this is basically when we have a capacitance, when we have a load capacitance, when the pull-up network is on, if this network is on, our current source will go to the ground via this capacitance. So here this will get charged. So we have a charged capacitor now. So this is when pull-up network is on. This is charging of the capacitor. And then when the pull-down network is on, this capacitor gets discharged via this NMOS network. So when this is occurring, we have P switching. So there is a switching power. This is given by the formula alpha CVD square VDD square F. So where alpha is activity factor, C is capacitance, and VDD is supply voltage, and F is frequency. And another reason for dynamic power dissipation is short circuit power. So this is nothing but when this and both the pull up and pull down network are on, we have a direct path from VDD to VSS. So there is short circuit of the